Thank you. Good afternoon to you. It's a real privilege to be here with you and to thank you to the committee to invite me. I would like today to talk to you about CROSSRAIL and my experience in CROSSRAIL, to first of all briefly set the scene, to explain what the project is about for a few moments, and then talk to you about the information principles that have driven the project, to let you understand what BIM means to us on this project and show you how we have used it and how it's been absolutely critical to being able to deliver the project. And I have just a slide or two at the end to talk about what we call learning legacy, but that is where you can get a lot of information that we have created and explain to you the processes that we've used. So, first of all, I would like to just set the scene about the project. It is at the moment the largest transport construction project in Europe. It's about £15 billion in construction. That's, I think, about 60 billion Peruvian sol. It stretches from the west 50 kilometers to a 21-kilometer tunnel section and 30 kilometers to the northeast. The tunneling section here is the very expensive area, about £12 billion sterling, and that's where we tend to concentrate much of our work on in BIM. We have a whole raft of data and figures I could give you, but the clear indication here is that CROSSRAIL has a very good business case. We're employing some 14,000 people constructing this railway, and at the end of next year, when the project is open, it will increase the rail public transport into London by 10%, with 200 million journeys a year. The tunnelling work is now complete, going underneath the city. There were 5 main contracts with 8 tunnel boring machines. Each of the tunnel boring machines was probably the height of this room, 7 meters diameter. We've now completed the tunnelling, we've fitted out the tracks with, and beginning to fit out much of the systems in those tunnels. We have a number of different types of stations. We have 5 stations that we have enlarged underground. And as you can see here, the underground, those stations are about 3 football pitches in length. And that is a lot of excavation and material to move from underneath the City of London. We have 3 other major stations in London that are made by box construction that are some 250 metres long, 25 metres wide, 30 metres deep. We have to build all of this underneath London, and at the moment we're currently fitting out those stations with all of the equipment. And it is a really complex job trying to bring all of this type of engineering and installation in underground, and BIM has been pretty critical in making it happen. Above ground, there's a lot of new railway we're building as well in the stations and grade separations. But this slide gives you a little bit of a feel, I think, for at an existing station, 1 station there and 1 station there, existing railway lines and underground tunnels. But that green area there is the scale of the construction that we're trying to, which we are building underneath London, under extremely expensive and environmentally delicate real estate and property. So, building this type of construction and railway underneath the city is not easy. It's also complicated by the number of contracts that you need to put together to make a project like this work, because no one contractor can take this on board. So we have, again, a contractual complexity where we have 25 advanced works contracts. For 2 years, we had 23 consultancies. Most of the consultancy experience in the UK worked on our project for 2 years. And then we have another 80 construction contracts, varying from £400 million to £50 million. All of these contracts come together, and information is the glue that brings them together. It must be consistent and must work across all through these contracts to bring them together. I just wish if we had had one architect, one engineer, one quantity surveyor, it would have been so much easier, but we didn't. So in terms of the principles that we had, that we brought together back in 2008, 2009, my background to do this was I've been as an engineer in designing and construction of railways for many years, and then into project management. But we realized that the information was going to be such a key resource in creating this railway that it needed specific attention, particularly to try and get the coordination and the collaboration that's needed on projects of this size. So it's so interesting when we talk about VDC, because in CROSSRAIL we always talk about building two railways, the physical railway and the digital or virtual railway, and always thinking about those two things because they are inseparable. The digital railway will be used for managing and maintaining the physical railway for 120 years or more, so it has to be right. Its quality has to be as good in the digital world as in the physical world, and I'll come on to that a little bit later. So we have to have a strategy. When we started this 2008, 2009, we did not use words like BIM execution plan, but you need to, when thinking about any project, you need to think about how you're going to go forward and collect your information. So we had a strategy which at that time was thinking about the world of technology, because when we started, these things were not invented, and we use them every day. We had to think about this information, how it was going to be used, and we had to think, so we talk about adoption into the infrastructure manager systems. So how is that information going to be used in operation and maintenance? And then the world of working with our contractors and our supply chain, who have most of the really good ideas that we want to use. So if I had one slide to say what one needs to do in making BIM work in your project, in your area, in your company, it's this. It's about the need to define why you need information. The information that you use is for, usually it's either for making decisions, or there is some legal reason for having information, but you don't create information just for fun or just to store it. You create information for making decisions. Decisions of how to build the railway or how to operate and maintain. But it's about defining that information requirement at the beginning. Then simply defining the processes and the way in which you're going to collaborate and work to create that information and use it. And we call that in our BIM world creating our common data environment. And we made sure, and we use the words electronic document management system, electronic CAD management system, and we create those systems as a client, and we make sure that everybody uses our systems. So all of those contracts, 120 contracts, all use our systems in our common data environment. And that suddenly means that all your information is brought together in one place. And what you can do is use some of the fantastic technology that people have to help you you create that information. It's as simple as that. You must not be led by the software product solutions. You must be thinking about the information need that you have for building and then for operating and maintaining. So when I was a boy on site, I remember how everybody used to have a copy of everything. Everybody had copies of drawings, copies of reports, copies of information. And that was okay, but it was very hard to control. In our BIM world, in our common data environment, there is only one current version that everybody can share and collaborate in. And that's what the concept of a common data environment means to us. A big project or a little project, that is still the way in which a common data environment should work, that everybody has access to the particular areas, but it's as simple as that. And really, for us, the origin and start of that was based on some simple British standards that began in 2007, 2008, and they talked in there about those standards about common data environment, but also set out how different types of different disciplines can work together, and workflows for how you can create and get collaboration. And because it's not complicated, but it can be quite unusual for people to understand how they need to share and work together. But that is what the heart of BIM is about, and for us, that is where the word common data environment began. But that common data environment can be heavily influenced, and the way in which you work, the BIM environment, is heavily influenced by the conditions of contracts that you may use. And I'm going to be talking for a little while less about technology, but more about these types of things. So for example, the way in which we deliver the project was fairly traditional, but we used a target cost contract. Very complicated, complex contracts may require people to be paid on a time and materials basis. Really more simple contracts, people can be paid on lump sum. But where you have contracts that are large and complex, target costs are a good way forward, because you can agree with contractors what your costs will be, and you can vary them as you go, dependent on situations, and also dependent, for example, in our case, how technology can change the way you want to work. And we adopted target cost, and we were not too worried about price. Seems a bit crazy, but in fact, we awarded most of our contracts on quality. Interestingly enough, also most of those contracts were also the lowest cost, because we gave our contractors a long time in which to understand what their tenders were going to need to look like. Also, it takes a long time to put together your BIM environment. It took us a whole number of years, back in 2009, 10, 11. That's really when it happened. The codes of practice that we used was this small code of practice here. Because actually the BIM principles of understanding what information you need, understanding how you create a world to collaborate in, are really, really simple. You don't need to worry too much about standards. You do need standards, you do need process. But if you really work at understanding what your information needs are, it can work, big projects or small. So our common data environment began, our common data environment began back in the 2009, but continues to develop all the time. And when we talk about information, we actually talk about information types. 3D models, really important in the early days of the construction and operation design, where 3D models are everything, because they enable you to make quick decisions about what it is you're trying to design, what it is you're trying to build. But when you get towards the world of operation and maintenance, actually, and if you remember the slides from yesterday, where people say that in fact in terms of cost, most of the cost is in operation and maintenance, you're into the world of data models, models that are trying to predict when your assets might fail, so that you can repair or replace them before they fail. All of the scenario plannings that you have for maintaining your infrastructure rely on data models. It's still BIM modelling. The most important BIM model in our CROSSRAIL is our timetable. It's not a 3D model, it's a timetable. That is our most important model that affects our 200 million passengers a year. How do we get there? Well, there are many diagrams and processes, but again, the BIM world that we're in doesn't tend to change about what we need to deliver in terms of drawings and models and designs, but it's much more specific and prescriptive about what's needed. So at the early stages, just defining what our needs are, procuring them, going through the production at different stages and different times. When we talk about level of detail, we talk about not just level of detail of a model, but the types of information that we need at the different places through the process of creating, designing, building, and bringing into use infrastructure. The important thing here, back to the question of operation and maintenance, is it's really important when you define your information that you get the operator and maintainer viewpoint involved. One of the big lessons learned on CROSSRAIL for me is making sure, for example, at the design stage, I start the operation and maintenance manuals then. We didn't, and that's been a problem to us. But those design and operational needs should be actually thought about in those very early stages. So we need to think about how we're going to use this information, because in building a railway like this, there's a huge amount of information that you create, but only some of it is needed for operation and maintenance. And you need to define and understand all of that world. And we did that, and interestingly enough, the basis of our common data environment is shown on this slide, which is where we have put 95% of all our world, of our information, sits in 3 databases. And I'll explain that a little bit more, but it's a database where we have all our GIS and all our mapping, database where we have our 3D modeling world, and a database with all our information world. When we were back in 2009, beginning our world of CAD and GIS, we did come across a problem, and it meant that in this world of documentation and the like, we had a problem. And we sat back for a while and suddenly realized that we could have made this project very difficult, because all of the people, from a project management point of view, all of the specialists each wanted their own software. People wanted specialist software for accounts, specialist software for document management, document control, specialist software for managing the assets inventory. And we decided we would not do that. We decided that we would actually begin to look at how those processes and activities could be undertaken by workflows in those databases. And that was pretty critical to us, because it meant that the majority of that information world, and in terms of CAD drawings, and all the information that's created in design, construction, specifications, certification processes, all could be contained in those 3 databases. I was so interested this morning in hearing about the use of SAP, because there were 1 or 2 other databases like SAP, which were very hard to try and get underneath the bonnet and get inside. And so we had to use a world of data warehousing to be able to pull information out and go offline and create a lot of the reporting that we needed. But this common data environment I talk about here was critical to us. And you can see here, I hope, what that means. The processes in each of the databases there, the workflows, were workflows of processes and activities that everybody would use. For example, the contract administration, £8.3 billion, 10 billion US dollars. Well, the contract processing was done using workflows in a simple database. Document management was used in workflows in that database. And what that meant, that from an information management point of view, is that we were collecting all of that information in one place. And we could then relate it to, relate contract information to asset information, and we could begin to see that we had a world where the relationship of all the drawings and documentation came together. But it was a world where that single source of truth gave us many, many benefits, that everybody was using the information from a single place. What made my finance director really happy, though, was that, in fact, it meant that it was significantly cheaper to work that way than to have lots and lots of individual pieces of software trying to be used in your project. And I hope there are not too many people from IT here, but it also meant we could have a lot less people in IT on our project, because things were much more simple in managing and controlling the project. That common data environment meant that we could join up different types of information. We could link drawings and models to asset inventories. This diagram shows in the middle the asset breakdown structure. The backbone of information on our project comes through our asset breakdown structure. Linking and we can then link all the documentation to that, drawings to that, and all the other things that are needed for building and then operating and maintaining the railway. Absolutely important there is that concept of relationships between different types of information, because then the thing with CROSSRAIL is the speed in the use of the CDE is the speed at which you can then pull out that data. You don't need to worry about what type of software you need to use. Just be prescriptive on file types. And that was really, really important, because let the supply chain worry about interoperability. You just say you want particular file types as the product in the information terms. This does mean to say, as a project, you need to have different specifications and procedures that you have to write to tell people how to work together. You need to create your world of design reviews and processes, which we did, based around our 3D modeling world. And that creating that asset information, which is vital for the future operation of the railway, you need to have a plan for that, because we needed to recognise that there was very many inconsistencies in defining assets. So we created our own asset data dictionary that enabled everybody to understand what we meant by a railway sleeper, or these. Is that a bottle? Is that a container? Is it a mug? Different people, different interpretations. And as a client, you need to define that precisely. And then you need to lock that into your terms and conditions. Back to the world of saying that if you do not get your conditions of contract right, with the type of information requirements, you will not achieve your BIM solutions at the end. So getting those details into your contracts is important. And then for us, it was about looking also at going and taking advantage of now the point cloud survey and scanning technologies to be able to show to everybody that what we got was what we wanted. So again, interesting when you can compare the physical world of quality control to the digital world of information. Quality control in concrete, you take concrete cubes or steel, you may take steel coupons and test them. You need to be looking at the quality of information that you create in our BIM world, because that end virtual model needs to match the quality of the physical. So we have here in lots of information quality control of CAD world of models, on document control, on the asset inventory that we're collecting, to control the quality of the information products that are being created. And so when we take all those principles and we look at how we put that together, we can begin to see how this works when we're using things like a GIS early on in our days, where we would, for example, here, we can look at a map and we want to look at a particular building. We can take information out of our GIS, we can take information from our design about a settlement curves, understand buildings, details, quickly create a drawing, and then in about 30 minutes produce a report that used to take us about 2 weeks. And here in this case, about the potential damage on individual buildings from our tunnelling. And when we have 5,000 buildings along our route that are affected, it's important to be able to do that quickly. Here, for example, is where our CROSSRAIL tunnel at Tottenham Court Road, it's in yellow. It goes above one of our existing railways called the Northern Line in red, in one of our stations. And we had to put this model together to show the complexity. And when you bear in mind that the distance between the existing structure there and our 7-metre diameter tunnel is probably no bigger than was 83 centimetres. Being confident and trusting your information is really important. If we were not confident in our information, we would have had to move that yellow tunnel some 10, 12 metres down, and that would have cost us another 500, 600 billion pounds. So having good information and managing it well also has significant impacts and enables you to make better decisions. When we go into design, everybody is familiar, I think, with 3D models. 3D modelling has been around for a long time, but in the BIM world, it's about actually managing space better, coordinating space, taking out the wastage. For us, taking out at least 100 million pounds of wastage by better coordination of the different design disciplines. We used our 3D models at specific stations where we needed to understand some of the contract interfacing, some very big tunnelling contracts meeting some difficult stations. These models enable people to make better decisions, more informed decisions about what was happening in those confined underground spaces. And also sometimes we would make small models to show a construction method. Here we have in 15 seconds a quite complex construction process that we wanted everybody to understand, because the importance of getting this right at where our tunnels met and crossed over into 2 lines was absolutely critical. This was built 15 metres, 20 metres underground, and you only had one chance of getting it right. So design little models would help there. We'd also create models to show how we would want our sites to be best used. Some very constrained sites, and we could optimize how they get used. Under the ground, very constrained, and our models would help people understand here what areas could be used when, and here where we were looking at how we would construct the track, very complicated parts of track where we had floating tracks on springs, to show the logistics of how we could put that together and then get the timing right. Here, underground in our stations, where we have many trades working all at once in confined spaces, to show how the work underground needs to fit together quite precisely, almost like trying to build a car in a very confined space. Getting those trades right, so people understood when they had access to particular areas, was pretty critical. We would also, every 4 weeks, produce a report where we would actually take the 3D model, and we use the 3D model to report on progress and acceptance of design. And effectively what we would be doing is looking at how much had been built, so it could then be signed off. And this was taking the 4D model into the 3D model into 4D and 5D, where we could then link that to payment. And the reason the contractors were very keen to get on board with doing this, because they got paid a lot quicker, and we were very keen from a client point of view, because we knew there was no hiding place, because we were going around sites with our iPads, collecting this information and putting it back into our common data environment, managing and processing and recording the progress in that way as well. Didn't always work. Sometimes people made mistakes, and if it was not right, we ripped it out and we had another go. And this information has to go into operational maintenance. Very quickly, we had 4 different operator and maintainers, and the advantage of using our common data environment meant that we only collected the information in one place, and then we could take an idea that Apple created in the world of the iTunes, which was where we have different contracts coming together in one station. We collect the information using templates, bring all of that information into our common data environment, and then create playlists of that information that people could then use in operational maintenance. And where the importance of that is that we often have 2 or 3 organizations, maintainers, wanting the same piece of information. And instead of giving them copies of that, they can use that information from a single source of truth. And here is an example where we have London, we have Rail for London wanting to use Maximo, that piece of information, and we have London Underground wanting to use the same piece of information using Ellipse. 2 completely separate asset management systems, but they can access that same piece of information if you become data-centric in the BIM world, which is what you want to do, and not application-centric. Don't lose all your information in applications. Applications change, people change, technology is changing. Your asset data does not change, therefore the concept in a BIM world is to keep your information central. So we can then hand over our models. I'll have this on our iPad that our asset operators and maintainers can then use. The benefits, I'm running out of time, so I won't go into too much of the detail because you will get a copy of the slides. But significant reduction in wastage, the world of our common data environment, absolutely critical to getting that collaboration between all of the contractors and designers. The savings are significant. Absolutely extraordinary sums of money. But it's actually about improved efficiency as well as effectiveness. Efficiency in terms of time saving, effectiveness in terms of quality of information that you get. You've seen that slide, shows you the cost of the savings in the CDE. But interesting for me was some of the softer benefits of working in a BIM environment, which was to do with safety. The fact that technically, tragically on CROSSRAIL, one person lost their life, but normally there would have been 8 people on a project this scale. The use of information to help keep people safe has been pretty critical. All of the information, much of the history of CROSSRAIL, all of the scars and the pain that we've had is actually collected in our what we call Learning Legacy website. In there it explains, I think many of our engineers, many of our people have written papers. There's over 100 papers there which give you some of the history of CROSSRAIL, the good and the bad, the difficulty. You know, I used to have dark brown hair when I started this project. It's just amazing what it does to you. But in there, you'll see lots of papers about what it's taken so far to deliver CROSSRAIL. And in one sort of final slide here, CROSSRAIL is a big project. It's a very expensive project. We have many thousands of people working on this. We're running all the systems as a client to make it, try and bring it to come together to create one railway. And it would be so much harder without BIM. So, muchas gracias. Thank you.